Inequalities, Lesson 2. So it's Unit 2, Solving Inequalities, Lesson 2. The homework that goes with this is page 4 and 5 in the packet. This is other information that you may need. Now, I'm going to go over an example right now that is not in your notes, but you definitely want to pay attention to this because this will explain why solving inequalities is like it is. So I'm going to start out with, I am making this up, an inequality that is true. So 2 is less than 4. We can agree that 2 is less than 4. Now, I am going to transform the inequality. Just like solving equations, as long as you do something to both sides, you're allowed to do it. So I'm going to add a number to both sides. I'm going to add 2. So I get 4 is less than 6. Is that still true? Yes. So I just showed that you can add a number and the inequality remains true. Let's show subtracting. So again, let's start out with 2 is less than 4. Well, let's subtract 2 from both sides. I get 0 is less than 2. That's true, so we can subtract. So I just showed that we can add a number and subtract a number, and our inequality remains true. Now, let's look at multiplying and dividing. So I'm going to do 2 is less than 4. Again, that's true. Let's multiply both sides by a positive 2, and I will get 4 is less than 8. Still true. So multiplying by a positive. The inequality remains true because 4 is less than 8. Let's do 2 is less than 4. Let's divide by a positive. So if I divide both sides by 2, I will get 1 is less than 2. Still true. So I've shown that I can add and subtract, multiply and divide by a positive, and it doesn't change the inequality. Now, we've got to multiply and divide by a negative, and this is where things get tricky. So we agree that 2 is less than 4. Let's multiply both sides by negative 2. Now, look what happens. This is going to be negative 4. This is going to be negative 8. But think about a number line. Isn't negative 4 greater than negative 8? So when I multiply by a negative, I need to switch the inequality. When you multiply by a negative, you need to switch the inequality. And I should really say multiply both sides by a negative, because negative 4 is greater than negative 8, so you need to switch the inequality. Let's look at dividing by a negative. So again, we start with the inequality, 2 is less than 4, which we know is true. Let's divide both sides by negative 2. 2 divided by negative 2 is negative 1. 4 divided by negative 2 is negative 2. Look, negative 1 is greater than negative 2. So again, if you divide both sides by a negative, you need to switch the inequality. So if you multiply or divide both sides by a negative, you have to switch the inequality. Everything else about solving an inequality is exactly the same as solving an equation. So go in your notes to the first page. This is page 2. Adding and subtracting inequalities. Same as solving equations. The same as solving equations. You need to graph your answer. And we'll look at some examples in a minute and you're going to understand. Multiplying and dividing. Put a star. Key point. If you multiply or divide both sides by a negative, you must switch the inequality. inequality symbol. So, and then you're going to graph. So, solving inequalities is exactly like solving equations, except if you multiply or divide both sides by a negative, you need to switch the inequality. And you need to graph this. So, let's look at some examples. Draw your line down the middle, just like you do with an equation. How do I solve this? I subtract 39 from both sides. So I get x. Do I switch my inequality? No, because I'm allowed to subtract. So I keep my less than or equal to. 100 minus 39 is 61. So our answer is all x, such that x is less than or equal to 61. So let's draw our graph. 60, 61, 62. Since it has an equal to, it's going to be a solid circle. Which way is less than? It's to the left. So that's what my graph looks like. The answers are all x, such that x is less than or equal to 61, and that's what the graph looks like. Example 2. Let's add 3 to both sides to solve this. So I get p. Again, I do not switch my inequality. P is less than negative 2. Here's my graph. Less than. I'm going to open circle, because remember, when it's open, you have a, when it's just less than or greater than, it's an open circle. Less than is to the left. All right. I'm not going to worry about these two. Now, don't forget, if you multiply or divide by a negative, you need to switch the inequality. So, solving this one, I'm going to divide both sides by positive 4. So I get x is, I do not switch my inequality because I divided by a positive. You only switch it when you multiply or divide by a negative. So this will be x is less than negative 4. So again, my graph, open circle, shaded left. Because there's no equal to, and less than goes to the left. Now, example 2. I'm going to divide both sides by negative 80. So I'm going to get p. Ding, ding, ding. We divided both sides by a negative. So we need to switch our inequality. So a greater than becomes a less than, and it'll be negative 10. So, there's negative 10. Open circle, shaded left. As you graph your final answer. Do not forget, if you multiply or divide by a negative, you need to switch the inequality. All right, how do I solve this one? I multiply both sides by 4. So I'm going to have t is, do not switch the inequality because I multiplied by a positive 4 greater than 8. So here's my graph. T is greater than 8. Open circle on 8, shaded right because it's greater than. Always make sure your variable is on the left before you graph it. All right. This one, I'm going to multiply both sides by a negative 2. So, I'm going to get x is, you need to switch your inequality because I multiplied both sides by a negative greater than negative 2. So, there's negative 2. Open circle, shaded right for greater than. Do not forget, if you multiply or divide both sides by a negative, you need to switch the inequality. Other than that, it's exactly the same as solving equations.